Hello everyone and welcome to the Offensive Software Exploitation course. My name is Ali Hadi and I will be your instructor for this course. So this is our first session going over a couple of theoretical stuff. Whatever is going to be represented in these slides, they represent my opinion. There are many references you can check, but also some of them represent my personal opinion. So first thing is we'll go over vulnerability identification. What's a vulnerability? Just the basics. So that's what we'll do here. Also understand this is kind of I would say, what's the quick road to bug hunting and what is bug hunting actually. So this is the outline, the topics that will be covered in this session. So first thing before we start talking about exploitation, which is the main goal of our course, is to understand what do we mean by vulnerability? What do we mean by security hole? So those are two things that you might be hearing, especially if you're new to information security. That's why I called it InfoSec 101. So a vulnerability or a security hole is a weakness. It could be any type of weakness, by the way. It could be in an application. It could be in hardware. So it could be in either one of those. So it could be in a hardware. It could be in a software. And the idea is this weakness allows a threat actor to gain some advantage over if it's a system, then over the system. If it's a hardware, over the hardware. So again, a vulnerability or a security hole, it's a weakness in an application or in a hardware which allows a threat actor to gain some privilege or advantage, let's say, over that system or hardware. So bug hunting, what's bug hunting? It's a process of finding these security holes, I would say, or vulnerabilities, okay, whether in software or in the hardware. So the idea is, what's the process that what's what bug hunting is? Is what's the process that you will take to find these bugs? And here I'm talking, by the way, about security bugs only, because not every software bug or hardware bug is exploitable or leads to an exploitation, and we'll see that in other sessions later on. So the idea here is to hunt those bugs which are actually they represent a weakness in that software or in that hardware. Okay, so what do these security bugs allow a threat actor or an attacker to do? So one of the things is they allow the threat actor to remotely compromise a system. So imagine you have a server where it's running some network service and an attacker sitting behind his computer somewhere on a remote location. He can send some code, and that code, once it gets run in the network service, it will give the attacker an advantage over that computer which is running the network service or the server. So it's compromising the system remotely. Also escalate local privileges. So imagine, let's say, if we go back to the same example, so imagine as a threat actor, you gained access using this network, and now you managed to reach the system. But the problem is, let's say you found out that the system that you compromised, you are running with a normal user, so it doesn't give you quite, let's say, good advantage over the system. You still are. It's still good. Not saying it's bad, but we need to elevate our privileges. And here, what that means is we need to take our privileges or escalate them from one level to the other. So let's say you compromise the system, you gained normal user access, and you want to go up to administrator or maybe even system on a Windows machine, or root on a Linux machine. So that's what local escalating local privileges. Cross privilege boundaries, think of it like this. If you have a good idea about operating systems, and I highly recommend you go and read about OS, is usually applications are running on a system, they are separated between, let's say, two two zones or two running privileges or boundaries. One is running in user mode. So some of applications which us as normal users run, they will be running in that user mode, while the kernel, the core of the OS, is running in another mode called kernel mode. So you might be able, with these bugs or these security holes or these security bugs, you might be able to cross boundaries, which means you might be able to cross your privilege from a user mode application to gain into, let's say, a kernel mode application. So you manage to cross boundaries. Wreak havoc on a system, so you might just be a threat actor could do actually anything. Once they gained the highest privilege on that system, they might just, let's say, just wipe the whole machine. So these are probably some of the main, or let's say general reasons why uh, a threat actor might want to do or might take advantage of a security bug. So fun and profit. So finding bugs in the past was for fun and getting like media attention. I did this, I did that. You submit your bugs and you get lots of good media attention for doing that. It's totally fine. It's totally okay, and it's totally good also. Or I would say it's nice. But today also you can take advantage of those bugs that you find, those security bugs that you find, and submit them to different organizations, which in return they will pay you for identifying those bugs. So there are lots of companies that have bug bounty programs such as Google, Facebook, Twitter, Red Hat, etc. So there are many of them. Zero Day Initiative, iDefense. These are just, by the way, a couple of just a simple list. There are so many other companies that will take your bugs and pay you for them. So, like I said, in the past it could be just for fun. Today, it's actually for profit, so you can gain a lot of money out of that. Taking advantage of bugs. So software, the software that takes advantage of the software vulnerability or the security bug or the security hole is called an exploit. So the code that is written to take advantage of the vulnerability is called an exploit. Okay, again, the code that is written to take advantage of this vulnerability, it's called an exploit. And exploits could be for use against applications, operating systems, protocol, etc. If you manage to gain if you manage to gain and I mean manage to gain you like find a bug or find a security weakness and exploit an application or let's say an operating system that's widely used, then you'll get huge media attention like the slide says, or like a hacking star. Like example, think of it like this: how many users use Google Chrome? Millions users use. So if you find a security weakness there and you manage to exploit that, then that will lead to a lot of media coverage and attention, and even I would say the pay, if you submit that, and you should submit that to get paid for it, then the pay will be definitely high. Same thing applies for other, like if it's for, let's say, Microsoft Word document, Microsoft Word processor, I mean. So if you manage to find an exploit for that application, it's a widely used application. It's very used, probably it's used daily on a daily basis by many people. So imagine if you manage to find a bug and be able to exploit that, the paycheck for that will be big, and again, you'll become a hacking star because of the media attention for that. Exploit language. So in my opinion, there is no specific language to write an exploit. It's totally up to you. Whichever language you feel comfortable with, I would say just use it. If you're comfortable in writing exploits in C, C++, Perl, JavaScript, any language, assembly, Python, name the language you want. just use that language. There is no like specific language that will say you must write your exploit in this language. There might be some parts of the exploit that need a specific type of code, but you still can write your exploit in many different languages. I prefer Python because it's very simple. It's uh, easy to use, lots of libraries. There's even when you like, for example, you get stuck on something, if you just Google, you'll find many answers to your problem. And using it to create a POC or a working exploit is not that complicated. And that's what we are going to use in this course. So uh, like I said, it's just preference, no reason other than that. So bug hunting formal process. So the idea is there like a formal methodology that if I follow, okay, like if you say, if I say, hey, go do 1, 2, 3, 4, 5, you'll get a bug. Do it again, you'll get another bug. Do it again, you'll get another bug. There's nothing like that. Because at the end, I believe that software is a human art. So two different coders or developers might be required to do the same function or the same program, but they will do them differently, or the code at the end will be differently, even though they both had the exact same requirements at the end, because humans think and differently. So that's why it's a human art. For that reason, in my humble opinion, I think bug hunting is also a human art. Excuse me. So, is there a formal process for finding bugs in software? I would say there isn't, but there's a couple of techniques. If we apply them together, or if we mix and match them together, we will get a good like lead on bug discovery. So the common techniques are divided into two main subcategories. One is static analysis, and the other is dynamic analysis. And by the way, each one of them has its pros and cons. So static analysis, here we will be talking like, let me just, yeah, it's covered in the next slide. So it's divided into static code analysis and reverse engineering. Dynamic analysis is debugging and fuzzing. And now, like I said, each technique has its ups and downs or its pros and cons. So bug hunters usually mix them up. So it's better to mix them together to get better results, because you can't just say I'm going to go with this approach and that's it. You might do it, will work, but it might not work all the time, because also, by the way, bug hunting also depends on the quality of the code which you are hunting or you are testing. For example, if the quality of the code is good, that means it's going to be a little bit difficult. But if the quality of code is not that good, then it might be easier than you think. So static analysis, like I said, is divided into two. This one is also divided into two subcategories: static code analysis. In this part, this means we need the code. The code is needed. We need to see the code. So we have the code. We can read the code, and based on our reading, we can understand it and find if there's any vulnerabilities or weaknesses in that code. Now, this is tedious and time consuming because it requires a lot of time to go through the code. Imagine if you had an application which is like 3,000 lines of code, and that's, by the way, just a very simple application. Imagine if you have a system which has hundreds of thousands of lines. How will you do that? It's very complicated. And another important thing which makes this complicated is it requires high knowledge in the language itself. So, for example, if you're static analyzing some C++ code, it means you really must have good C++ understanding in order to be able to uh, to analyze the code. I wouldn't say it's a must, but I would say it's definitely an advantage over someone who doesn't have that. Because sometimes you might be very good at programming, and just by looking at the code, you understand that there's some fault in this code which might lead to a weakness. Now, this type of analysis is very expensive, so keep that in mind also. It's very expensive. The other static analysis method is doing reverse engineering. So we don't need the code, we only need the binary, the executable. We have the executable, we can do reverse engineering, like use an IDA-Pro, or you can even do it in a debugger, which just gives you those disassembled code. You'll be reading just like assembly code. So you only need the binary file. It's also time consuming because it's now you're looking at you're trying to find weaknesses, not in a high level language, but now in a very low level language, which is assembly probably. So that's why the technical skills in assembly that you need is very high. Is it expensive? I would say it's also, yes, it's also expensive and time consuming. So dynamic analysis is what we will be covering in this course. So the whole course is going to be about dynamic analysis, which we cover these two parts. One of them is about debugging and the other one is about fuzzing. We'll have a session for each one of them. So that's why we are not going to mention them. But debugging, yeah, like you run your application or the tested application, let's say in a debugger, and which is an application that you can control the tested application itself or the tested software itself, and yeah, you can have control over it. Fuzzing, I would say, just basically now until we get to the session, it's by, let's say, sending some garbage data and see how does the application respond to that type of data. Now, the static analysis, like the reverse engineering and like static code analysis, those are both not covered in this course and they are out of the scope, but I will refer to some good resources which you can go and read about them. So general bug hunting methodology, like I said, there is no one method, but we'll like mix and match a couple of techniques. So first thing is you need to understand the application you are testing. Especially here we are talking, the whole course is about offensive software exploitation. So we're talking about software. We won't be talking in this course about any hardware. So you need to understand the application that you're testing. So you need to, and here first thing maybe is to read the specs and the documentation. Understand what this application, how does it work, what's the documentation of this application. Read all of it. How does it work, what type of data does it take, what is it used for, what's the purpose of this application, is there any like business logic behind the application. Okay, you need to understand all of that. So reading the specs or the documentation is very important in understanding how to approach and attack this application. Examine the attack surface. What I mean here is, what type of inputs does this application take? From where does it take them? Is the input to this application from the network? Is it from a browser? Is it from, let's say, some client application, a specific client application? You need to understand all of those. Does this application take a configuration file? Does it read some configuration file? Also, you need to understand all of those, because those are all ways you can use to take advantage of this software and, let's say, try to corrupt this software. So other things is identify target components an attacker would hit. Is like, think of an attacker, think like an attacker to defend better, uh, like trying to hit the database for SQL injection. So if you're a threat actor and you want to hit a SQL injection, what are the components that you would need to target in order to trigger a SQL injection? How will you do that? Like, you need to put yourself into the shoes of the threat actor. Putting yourself in that spot will give you an advantage, or would give you like let's say uh, it will open your eyes to the ways that you could take advantage of this application. Same thing, another example is try to upload a file. Let's say you have some web application. Can I use it to upload a file? Because if I can't, then probably I can upload this file and then execute it. So think of that. Can you like spawn a shell or spawn a process? Like, if you manage to do if let's say uploading something or running something will lead to creating another process. how will you be able to do that? How will you be able to spawn a shell? Like that process could be a shell, and a shell here means like it gives you remote access or control over the system. So these are all ways you can use to do general bug hunting. Okay, so what leads to bugs? There are many different things that could lead to a bug. Miscalculations, like for example, a developer, instead of calculating, he's copying some data from one, let's say, from one source to another, and the source which he's copying from, it has data bigger than the destination, which will lead to some overflow, which is what we are going to be covering in this course. Failure to validate input. Think of it like this. Let's say you have some application where it requires a username and password to log in, but it fails to validate the username and password, which means then the threat actor could send some garbage data, and it will lead, let's say, to failure in the login process. And that means if you had a system which is going to be your uh, first defense mechanism to reach the service which you're offering, then that first defense mechanism now has crashed because of validation failure. Failure to understand an API, like you're using some API, let's say, to integrate your application with another application, but you fail to understand that API, which could lead also to bugs or security bugs in the applications, because the way the API you are using to integrate with the other application is probably not used properly. Failure to validate results, whether they are operations or functions. So let's say you have an application which does some processing, and then that process uh, you fail to evaluate how that operation in general works, how those functions in general work. So there is no validation on, let's say, function A does something and then sends that data to, let's say, another function. Okay, you didn't validate that output which came from one result or from one operation and going to the other operation. Application status failure. So let's say an application, like each application might have different states, and these states, each one of them leads to some failures. So you did not validate all, I wouldn't say all of the states, because it's tough to validate all the states that might happen, but let's say I always like to give this example, one which is probably, if you have a software which requires some internet activity, and you run the software and it tries to reach the internet but it doesn't, and because you didn't validate that if there is no internet, then like give the user some pop-up saying, hey, there is no internet, there is no internet connection. So instead of just crashing, it will give you that pop-up, and then the user will understand, oh, then I don't have some internet, and then they can fix that. So failure to validate those states of the application will also probably lead to bugs and security bugs in specific. Complex protocols, especially today, we are dealing with lots of complex protocols, even TCP/IP. These are complex protocols. They have lots of they are based on lots of blocks of data structures. Those data structures, failing to validate every single piece of them, could also lead to a security bug. Or if you have an application which is like using its own, let's say, protocol, then also failing to validate that protocol and all the pieces which it's using could also lead to a security bug. Complex file formats like Word documents and PDF files, those are, I would say, really complex file formats, because I recall I did a long time ago research on PDF. Uh, So we studied a lot about PDF, and I recall the documentation for the PDF file format is more than I would say 1,000 plus pages. Uh, so imagine that big of a file format, and you don't validate everything. It's hard to it's hard to actually validate everything. So such complex file formats, such like I said, PDF, Word documents, they are hard to validate everything and make sure none of them leads to bugs. So those are good, I would say, targets where you might find bugs in them. Complex encoding, decoding, and expansion methods. So if you have an application which is doing some encoding, decoding, and the method which is used for that process might be some complicated approach. Also, those could lead to vulnerabilities and to security bugs. There are others probably, but these are, I would say, the most common methods which might lead to security bugs. These are the references which I depended on to create these slides and most of the other, I would say, slides in this course. So I would recommend like to go check them out. And that was it for this session. It was just an introduction. I think we have one or two more sessions left, and then we'll start diving into the hands-on, which I'm sure is the fun part and everyone is waiting for. That's it for this video. I hope you I hope you learned something from it, and see you in the next video. Thank you. Bye bye.